Hello, my name is Umar. Today I'm showcasing a project. This is like a website, a publisher, a portal, we can say a knowledge hub of experts in the field of AI, machine learning, quantum computing, things like that. So this showcase basically demonstrates the ability to a specific business case and then design an architecture around it, and what kind of unique learnings and unique insights that I can share while demonstrating my personal skills. So there are four. The first is basically talking about the strategy, understanding the niche requirements, and then therefore design, laying out the architectural design, how or what kind of decisions dictate architectural design, and what the stakeholder needs to understand. This is also business users and decision makers who can therefore understand what kind of decisions dictate an architecture. The second part of the video is on what is the difference between a database and a warehouse in applications. What is like the cost differential? What is the decisions that we need to make, and who can design? Does anybody can work on both? The third is basically curating data. We had to kind of like report news and report insights and give recommendations to people who are coming onto the portal and stuff. So that kind of requires LLMs and all of those intelligence, fine, yes, but also human intervention of curating data. Now that curation needs to happen from an analyst and a business user. Now that person might not have a skills. So we used a tool called Retool, but there are alternatives is like Airtable and other things as well, which are no code or low code platforms in which you can design applications. And so we use Retool to our satisfaction. And then so there's going to be a demo on that. And then fourth is basically how do you design something that is not uh, you know fully thought out or charted out. Basically, how do you build for future, and what a decision maker can make these head or tail out of this. So these are complex topics that have their own sections. So excited to get started. The ideal audience for this video is a person who makes decisions, even though if does not enact those decisions themselves. However, practitioners can also watch this, and see you in the next video. Thank you. Hello, welcome back. So, in the first section, we'll talk about the strategy. So, we're going to talk about, uh, you know, uh, this given this problem, how do we approach it? So, we kind of approach it, very simply by making a very simple diagram, and then we kind of expand it. So, this is like the basic architecture, which is the data ingestion. Data comes in, and then needs to be some kind of processing, which is like cleaning and standardization of the data. Understand that this is we're talking about reports here. So some entity that is already exists, a new version, a new name, a new information about that entity needs to empower the old entity. And so how to build all of that, we need to build structures. That's pretty standard warehousing stuff. And then we need to build a warehouse, or a database warehouse or whatever. That is a discussion for the next video. However, for the purpose of this, we finally landed on making a warehouse. Why did we choose it? We're going to cover it in the next section. um, this is like the warehouse, and that is enriched by the intelligence team, which is an LLM, or a physical human team, or some other AI algorithm. So the data comes in, it is clean, standardized, and intelligently curated. And then there's a website that people can interact with, and they can get their recommendations, get their advice, search for news, and all of those things. So this process is called ETL. I'm going to expand on this process, which is extraction, transformation, and loading. I think most people are familiar with it. What that means is that for every type of new data type, not each file, but for each data type, we need to kind of like write a utility to implement. So that is the part that cannot be automated very easily. There are several constraints there. Some things that we can maybe partially automate, I think, uh, but it still needs some tinkering. So that is expectation setting. The second part is then transforming. and then versioning, adding versioning, and then transforming, the data. And the third part is actually just landing the transformed data into like a warehouse. So this is, you can skip this part, but this is for the project that I did. No need to explain this a bit generic. However, this part is something that expands. So we have two different types of tables, which is a fact table and a dimension table. This is the terminology of a data warehouse. And so basically, this part, this white part, is further referenced over here, and it expands into this gray part basically. So this is equals to this part. It's just that over here it's denoted by 2 points. Over here it's denoted by basically, this is the fact table, and all of these are the dimension tables. Okay, so just zeroing back, the strategy is that we are going to like have this table. First, land this table, which is up till this point, cleaning and standard, and then implementing the intelligence. This is like the team that kind of curates or adds data. We're going to do that with a tool called vTool. This is going to be a big demo later on. But then once that data is curated in the master warehouse, we connect it to one big table. So this is the part when we have the ability to kind of nest the data and make it less complex, as well as the uh, you know the ability for to have one central place where everybody can just query and can ask the questions. So this so for the purposes of making it easy and simple, what we did was that after making a warehouse, we just made a kind of like a view, or kind of like connected materialized view, or kind of like a uh, interface, which is called the one big table. So this is all of this data is equals to this green part, and this looks small, but it has all of the data, and we can see how it is like we have everything is like an event over here, and the event has an ID, it's a date, the name of the event, the type, the content type. This is also with reference to this particular project. But then we have an event details and tags, which is key value pair, and within that it's going to have all of the details present. So how does that look like, and all those things we're going to see later on. But this is something that is the solution, and this is something that the person who is curating the data will be also be referencing, or it's going to be very easy for them to kind of reference. And then we're going to have all of these as the output tables, you can say. And yeah, that is like the uh, strategy. Hope to give more clarity in the upcoming videos. So stay tuned. Hi, welcome back. So today we will be talking about how a decision maker can navigate the world of tech stacks and databases and warehouses, and what these things mean purely from a decision maker's perspective, and how that can actually lead to a data strategy. We already are working on a case study where we have data that is collected from X number of sources, and we are making a knowledge hub, a portal. So, with this perspective, with this specific example, because our own data might have a database or not, we are still going to utilize that as one of the several sources that we have. So when that case is clear, what we will do is we will make a warehouse. Now that warehouse is going to have a number of data marts. Now, what does a data mart mean? So basically, that is the implementation of a warehouse. So you don't need to worry about that. Let me show you with a diagram, with the help of a diagram. This is commonly referred as a UML diagram or a RD. But you can see that one table is connected to multiple objects. And then there is something called zeros and ones, and there is a star. This explains the relationship between one entity and another entity. And so everything is an entity. And this is that we can see some are connected to more than one table, and they have certain relationships defined. And this is the basics of how a database looks like. So this is the same data, but in a warehouse. And you can see right off the bat that there is just one table that connects to all of the different other tables, while the other tables are not connected to each other, but to this central table only. Now, this is the visual difference. And you can also search on Google and you can see star schema, what it means, what it looks like. You're going to find something like this. There's a fact table, and then there are dimension tables. And then if you say database schema, then you can see something like this. All of these are interconnected with each other. These are connected, and then there's, or maybe this is a better relationship diagram in which there's a whole mesh of relationships and everything. Now, from just observing this, another question comes into my mind. If I have certain data over here, and I want to get data from this and this table both. This is, for example, a person, and this is the products, or the products purchased, and I want to understand. So I have to navigate through all of these connections. These are called joins in a code, and this is going to be comparatively quite complex. However, if I am looking at a previous example in which we have only one central table, so we know all of the relations are derived from this central table. Now, this table is going to be an absolute mammoth, is going to be big. However, it is going to support our analytical requirements. So people who are, it's easier for business users and business teams, and not wizards who are amazing at SQL. They can also work on this, have like central data mart to answer all of their questions. So this is one of the benefits of moving away from a database structure to a data warehouse structure. This is going to be cheaper as well as faster for analytics compared to a database. As a matter of fact, for database, if you directly build your analytics pipeline on a database, then it will be plagued by multiple sources of truth, maybe even, but it can also be plagued by redundancy as well as bottlenecks in terms of performance. So that is the difference between a database and a warehouse. And we might not need to make a very comprehensive warehouse, but we would still need to make the minimalist level of a warehouse, which is called a data mart. Now, having explained the difference of choice and the purpose of between these two, the others become easier. So a database is like a PostgreSQL, MS SQL, MySQL. These are things are referred as to as a database. And a warehouse is going to be Amazon's Redshift, Google's BigQuery, Snowflake, as well as Azure's Data Factory, or Azure has some other offerings as well. Then you have a data lake and a lakehouse. So warehouse and database require a lot of deliberation in terms of design. However, data lake is somewhere that you can AWS S3, Google Storage, Blob Storage by Microsoft. These are places like you just dump all of your data. And then when use cases arrive and you say, okay, now I want to query my data, you use something like Snowflake, Spark, Databricks. These are really popular tools which are designed for this, that you can just take your data out and build your design. But even then, you would need to make something of a warehouse design. So this is the purpose of when you use a data lake. So you can say data lake is a buzzword, a kind of fancy word that revolves with a warehouse and as well as a storage. So it is like the implementation of a warehouse. And this became more and more, you can say, obvious with time, that we were just talking about a special implementation of a warehouse. That it later bit now there's a new term that is that's the combination of a data lake and a warehouse, which is called data lake house, which is out of the box like solutions which use this configuration of a data lake plus a warehouse, which is called Delta Lake. And this is like a packaged solution which is doing the same. So these are different technologies. The configuration, it really does depend on what your team is used to, and and because from a cost perspective, these are expensive tools as well as the resources, the technical people that you need to hire are also going to be in a lot of demand. We are going to talk about a little bit of costs last time. So a database, it costs, for example, if you have configured it in a server, so just hosting that server, that would be the cost of the database. Same goes with a warehouse. But warehouse with cloud platforms like Redshift, BigQuery, these guys have free tier and quota limits as well, which is free per month. And then you after that you kind of pay. So I've set up warehouses for a lot of clients, and generally it's the cost is either less than $20 or $50 for SMEs. But for enterprise, there's just massive amount of data, and there's hundreds of users using premium reports every day. So the cost is around $1,000, $1,500 per month as well, which is all justified in terms of the scale of the and the value as well. But there have been even more premium and bigger total cost of ownership in terms of data. But I'm only talking from the perspective of the warehousing cost and the cloud platforms cost. So I think that covers this, and see you in the next video. Thank you. Hello, welcome back. This is the third video of the project showcase, and we're talking about a making a portal for experts, for which has expert knowledge. In order to do that, we need to kind of like curate the data while it is in the warehouse, and that curation does not require that you have someone who is an SQL wizard or who knows a lot about Python or any other thing to kind of do that. So we want to create a basic kind of like an interface, as well as we want to be able to kind of update and maintain it over time. So we need some kind of a tool which is a low code or a no code tool. So Retool is one of the leaders in that space. There are other alternatives as well, like Airtable. So let's go to the demo. So this is an internal tool that I've made, and this will be sufficient to show the capabilities of this tool. So I'm just gonna I just changed the date, and you can see that this is responsive, and more rows came up, and I'm gonna go ahead and uh, choose another person. That this is me. So this also updated. So this, how is this updating, and where is this connected to? I just want to. You can find how to make this. There is a lot of tutorials on YouTube. But if I just select this, this is called table two, and then I go to the code which is like the connections, and I can just going through this. I Table two is connected to the data source to-do list, and so to-do list, I go over here, and this is a bit of code that I've gotten through GPT. It also has a AI assistant over here, and this is pretty much it. This is SQL code from the database, and this allows this to be built. So once this is built, your team can easily make selections, change dates, and it'll get different things. This is like to-do list for internal purpose. You can also select anything, and all of these data is also going to be updated. You can see this changes, and while selecting, I can add an update task, and change the hours over here, and it can save. So this is quite comprehensive. But what we want, the design is not very good, but the design can improve. There is design functionality over here. You can change the color and the and yeah, I'm not very good at user experience or anything. So that was a bit of a demo, and kind of like a walkthrough over how easy it is to kind of build. You can make a yeah, dynamic connection. It'll take a couple of minutes, and you can also add more interactions like buttons, drop downs, and what happens when you click on something. You can also import your charts over here, like you have a Power BI dashboard or any other dashboard. You can embed those dashboards over there as well. So it's a comprehensive tool, and yeah, we got our work done through the free tier itself, but the paid seat is about $20 or something. So see you in the next video. Hello, welcome back. So this is the last video of our project showcase, and this is going to be about the versatility of modern tech stack, and explaining to the decision makers how you can have something that is variable over time. And let me explain what do I mean by variable data storage or something. Um, so basically, let's imagine you have a store, and you're making warehouse for different stores who buy and sell things from you. Some kind of an FMCG product. Let's take soaps. Now, for example, you have Walmart. Now, Walmart has different branches, and then you have a mom and pop store, which is very basic. And there could be different types of, for example, organizations. Some organizations acquire other organizations. Some have so many branches. Some have a lot of data, and some organizations, like a mom and pop store, has only one branch, has only three, or just one manager who has the billing address. There is no legal department. There's no XYZ things. But however, when we are trying to build the structure for an entity, it could have 100, 200 different fields, right? It can have a field on how many branches there are, what is the head of the branch, this, that. So it really becomes very hard for us to kind of categorize both entities in under the same umbrella and still not waste energy trying to, for example, you have 1,000 entities, only 15 of them are of category A, 20 are of category B. There are 5, 6 different categories, and there is just a complete mess. So how do you have something that based on certain kind of a category, you can change? and how compute looks, different as well. So basically, we're talking about JSON structures within within a field, an object or a nesting object in a field. So let's head on over to GCP's BigQuery, and we're going to do a bit of a demo. So this is the basic interface that opens up and you open BigQuery on Google Cloud Platform. I would really recommend this. This is a very good warehouse. And then I'm just going to select a property of Google Analytics data dump. So this over here, this is something that a lot of people, a lot of business decision makers really do have to work with. Google Analytics very popular, and I just want to kind of show over here that this is like a standard implementation, and over here you have a thing called event parameters. Now, event parameters has keys and values, and the value can be different data types. You don't need to worry about that, but understand the relation between a key and a value. And this is an event parameter which can be repeated. However, there are certain things which are non which are nullable, which are not repeated. So that's something that comes up in implementation. But there are certain things which are repeated, and this is what we are interested in. So we have user properties, we have traffic sources, we have actually traffic sources from different places. So let's look at some of the data. Let's preview this, and you can see that this is not just like a simple kind of a row. Rather, it expands. The first row has so many, you can say, nested sub columns, or sub rows, you can say. So what that means is, for one type of a entity, we can have 5 rows. For another, we can have 500 rows. And what that helps us with, so that helps us with having the ability to kind of like call both of these in the same thing, like an entity, like an organization. And while having that, we can also filter on the same, because both are going to have like a start date, the name, and the total money that they've brought in, something like that. And we can filter out organization based on certain criteria, and therefore limiting our search and then expanding into however many key value pairs it has, the JSON structure it has. So this is something that comes out of the box on GA4. I just wanted to kind of like show you that this is something that is industry prevalent already. And this, I've not actually done anything. This is just enabled a connection in GA4, and this starts popping up and doesn't really cost anything. And this is something that we can also build for our own selves, and this is what we kind of did, a custom implementation over entities and several other things. And Now, the last piece of the puzzle is that how do we know which type of an organization has what structure? So for that, I would recommend that you have a separate table maintained, which is like, you can call it the structures table. And that structure tables has a date and the structure of, whatever variable you have. And that is something that's like a reference point. Whenever you want to query this particular table, you first go to that reference table, get the structure, and from that point onward, you can write your queries and your automations. And yeah, and that was it. Hope you enjoyed the series, and you can always DM me to get in contact if there's anything that wasn't very clear or anything that you need help with. Thank you.